1.12 Solving and Graphing Absolute Value Inequalities. Today we are going to be solving and graphing absolute value inequalities so that we can find and represent solution values, particularly on a graph. So you'll be able to do it when you can isolate a variable and then represent the set of solutions on a graph. So this is going to be broken down into several steps. And then I'm going to show each step in its own little practice area and then move on to the second part of the step. So step 1, we will be isolating the absolute value. Step 2, we will then be splitting the absolute value into two equations. And step 2 we're also solving. And then step 3 we'll be graphing the compound inequalities. And then the last part of these notes, we will do all of those steps. You'll see examples of how to do all of those steps in one go. So the first thing is to isolate the absolute value. The first step is to get the absolute value by itself. Once the absolute value is by itself, check to see if it is being compared to a positive or negative number. If it is positive, move on to step 2. If it is negative, use the following rules. Absolute values greater than a negative number leads to all real numbers. Absolute values less than a negative number results in no solution. These, for the purpose of our class, we won't come across too many of them, but it is important to note, just like when we were solving absolute value equations, if the absolute value equaled a negative number, it was no solution. And that is because absolute value is a distance, and we do not use negatives to describe distance. So absolute value is the distance away from 0, and we do not use negative values to describe distance. It just doesn't work, so there's no solution. So with inequalities, there's a little bit of a nuance there, and again, you won't see it too often. So let's talk about isolating an absolute value. When we isolate an absolute value, what we're talking about, and when we're looking at this kind of inequality, you'll notice that we have what are called bars. They're our absolute value bars. And within our absolute value bars, we usually have like some kind of variable or an expression, some kind of couple terms, something going on. So inside the absolute value bars. The problem is if we have something sitting outside of the absolute value bars, like this 4, so this 4 is sitting outside of the absolute value bars, we have to get rid of anything that is sitting outside of an absolute value by solving for it the way we would in an equation. So if I have a 4 sitting right next to this absolute value bar, right next to our bars, it means it's multiplying. So this 4 is multiplying in with our absolute value, but we need to get rid of it, so we are going to divide it. We are not going to distribute it. We are going to divide it to both sides. That will make these 4's cancel out so that we are left with the absolute value of x plus 3. And I like to make my absolute value bars large so that I can tell that they're bars and not like a 1. And then 20 divided by 4 is 5. And then I'm still checking because I'm dealing with inequalities. If I divide by a negative number, it flips my inequality sign. In this case, my inequality sign does not flip. So there's the first example for isolating our absolute value. This is going to feel a little bit disjointed, but I want to show you just repeatedly so that you get a good idea of what it looks like. So for this one, here's my absolute value that I'm getting by myself. Think about it like this. If I had negative 2x plus 4 is less than or equal to negative 16, what would I get rid of first to get x by itself? I would get rid of the 4. So I would subtract 4 to both sides, And then after I do that and work that out and rewrite it, I would divide my 2. We are following the same steps, inefficiently erasing. We are following the same steps up here, but instead of having like negative 2x, we have negative 2 times this whole thing. So we're just treating this thing as if it's maybe like a variable, which means I would subtract 4 to both sides first. Which would leave me with a negative 20 on this side, negative 16 and 4. And then I still have the absolute value of x minus 7 in the bars and a negative 2 sitting outside. So now I'm going to get rid of that negative 2 that's multiplying by dividing it to both sides. So I'm dividing negative 2 here. That makes these cancel out. They turn into a 1. And I divide a negative 2 here. Remember our inequality rules. If we divide by a negative, our inequality sign flips directions. I'll write that in purple. So there we go. Now that guy's different. Okay, so he changes directions. And we are left with the absolute value of x minus 7 is greater than or equal to positive 10, because negative 20 divided by negative 2 gives us a positive 10. So this problem is not done, but this is the first step. I'm just showing you these first steps. And then we would check to make sure that this is a positive answer. If we have a negative answer, sorry, you're probably getting all dizzy as I zoom in and out here. If we get a negative answer, then we'll check this. If it's a positive answer, then we just move on to step 2. All right, let's continue working on these. Again, my absolute value is everything inside these bars. So I need to move the 5 and the 2, and I'm going to get rid of the 2 first. That will give us negative 25. I'm rewriting, these canceled out, is less than or equal to 5 times the absolute value of 2x minus 8. Now I can get rid of the 5 by dividing it. So I'm going to divide 5 to both sides. I'm checking to make sure if I divide by a negative, my inequality flips. These are positive, so my inequality stays the same. Now we are left with the absolute value of 2x minus 8, didn't give myself much room, is less than or equal to negative 5. So my absolute value is by itself. So now I'm looking and I have a negative. Well, remember our rule. If it's negative, we're going to check our inequality. If it's negative and it's greater than, so this is not greater than, this is less than. So absolute value less than a negative number results in no solution. So the answer here is no solution. If you want a little bit deeper explanation of why that's the case, think about, I'll use this space here, think about the absolute value of x, right, is less than negative 5. So any number that I put in here, let's say I put negative 2, the absolute value of negative 2 is positive 2, and positive 2 is not less than negative 2. This is not true. And that's for any number that we put in here, it ends up becoming positive, and that creates an incorrect statement. So that's why there's no solution when it's less than. I believe this one's going to leave us with a greater than. So let's take a look at this. It's the same problem. It just changed the inequality here. So we're subtracting 2 to both sides. Negative 25. I'm just rewriting my work. I'm now dividing 5 to both sides, even though that's a crazy looking 5. Those cancel, and now my absolute value of 2x minus 8 is greater than negative 5. And this would result in all real numbers. Because we have an absolute value being greater than. Again, I'll use my negative 2 example here. So if I did the absolute value of negative 2 was greater than negative 2, the absolute value here is always going to end up being positive, and a positive is always going to end up being larger than the negative we're comparing it to. So because of that, this ends up being all real numbers. If that's confusing to you, it's not like an essential piece of understanding how to do this, but I felt like it was worth taking the time to explain. Again, for the purpose of 1.12, we're not going to see very many negatives or be working with them. Okay, so we've learned how to isolate the absolute value. So we just practiced that here. If you notice the answers I got for 1 and 2, or for A and B, correspond with what we're working with down here. So the first step is to isolate. The second step now is once we've isolated, we have to split the absolute value into 2 equations. And this really should read inequalities. That was my bad. Into 2 inequalities. You don't necessarily have to change that on your notes, but so we're going to split the absolute value into 2 inequalities. The first one will be the same, and the second one will be flipping negative. And I'll show you what I mean there. And then we're going to solve each inequality. And you could think about it like this. We can't, we obviously need to get x by itself, but we can't touch anything that's inside of these bars. Okay? You all are minors. You can't go in the bars. You can't subtract 3 because you're not allowed in the bars. So we have to get rid of the bars. The way we get rid of the bars is by, you can kind of think about doing it this way if we have our absolute value bars. You can think about you're taking a bar. I don't know how well I'm going to be able to manipulate this. And you're using it to create your first equation there. And you're taking a bar and you're using it to create your second equation there. And then we just take everything that was inside the bar, x plus 3 in this case, and we are going to say it's the same as our original equation, so is less than 5. So I just, essentially my first equation, I'm writing this same thing down but without the bars. Now in my second equation, it's going to be flipping negative. And here's what I mean by that. I'm going to take the same thing, x plus 3, but it's going to be flipping. So I'm going to flip this sign around and negative. It's flipping negative. So I've created my 2 equations. And now we can go through and solve each equation. So my first one, I'm subtracting 3 to both sides so that x is greater than 2. In my second equation, I'm subtracting 3 to both sides to find that x is less than negative 8. One thing that you cannot do, a quick note, once you get your first answer, you can't use the opposite of it. You can't say, oh, x is greater than 2, so then my other one has to be x is less than negative 2. If you notice here, that's not the case. Sometimes it happens, but you need to go through and do the math every time. Okay, and then we'll talk about and or in just a little bit. But again, once we've isolated, so here I did all the work, right? I subtracted 4, I divide 2, then I get this, I get that left over. Once we get here, now the idea is that we're going to split it into 2 equations. The first one's exactly the same. It just loses the absolute value bars. The second one is flippin' negative. And I say it every time. It helps me remember. It's flippin' negative. And then we're just solving each equation. I'm going to add 7 here. So that x is greater than or equal to 17. In my other one, I'm adding 7. And x is less than or equal to -3. I'm just following my sign rules, combining my numbers. All right, example C. So because of these having no solution and all real number solutions as the examples, these are just 2 random ones that we'll continue using for the rest. So if you're given something like this, we're going to split it. We're going to say 4x plus 6 is less than or equal to 26. So the first one's the same. The second one, you guessed it, is flippin' negative. Like, I don't know how to show, like, how to draw your attention to that's what's different. I flip it and I make it negative. It's flippin' negative. And then we solve each. These are 2-step equations. So I will do my first step first, which is to subtract 6 to both sides. 4x is less than or equal to 20. Then I will divide 4 to both sides. Make sure that I'm not dividing by a negative. If I am, my inequality switches, but this is positive, so we're good. X is less than or equal to 5. So that's my first one. I'm going to go through and solve my second one. And I would suggest that you do one at a time. I wouldn't suggest that you do like, -6s all the way across and then divide 4. You're better off to just do one equation completely and then move to the next equation. Do it completely. So those cancel. We're left with 4x is greater than or equal to -32. We are dividing 4 to both sides. And we are finding that x is greater than or equal to -8. All right, and our last example here for these. We're splitting 2 separate equations. 3x minus 8 is greater than 12. So the first one's the same. The second one, 3x minus 8, is flipping negative. So there's our difference. The first one's the same, the second one's flipping negative. We're solving each. We should be really familiar with 2-step equations by the end of Unit 1. 3x is greater than 20. That's 12 plus 8. We are dividing 3 to both sides. Sorry to not color coordinate the other step when I added 8. Let's see, and we have x is greater than 20 over 3. What you will notice is in a lot of these, you may end up with fractions for one or both of your solutions. So here in my second one, I am adding 8 to both sides. These cancel. A -12 and a +8, we subtract to get -4. Keep the sign a larger number, it ends up being negative. 3x. And then we divide 3 to both sides to find x is less than -4 over 3. Okay, so again, we isolate the absolute value by moving anything that's on the outside of it. Then we split the absolute value into 2 inequalities and solve. The third step is then we're going to graph our solutions on a number line. So we're graphing both of these on one number line. And what you'll notice is inequalities, when they were split, if they had a greater than, they're going to be or, which means they're facing away from each other when they're graphed. Inequalities that were split when less than will be and are facing toward each other. So let's see, when we split this one, this is greater than, so this is an or. This is greater than, so it's or. This is less than, so it's and. These will be shaded, everything in between the points. And this is greater than, so this is an or. So I've already done the work here. You'll get to see it all solved out in one go, and I apologize, it's probably a pretty long video, but there's a lot of content to cover. A lot of it's review of concepts that we're just putting together. Okay, so on your work, you're probably going to have a number line, but if you need to create one, don't go through and -8, -7, go all the way up to 2. Give us some reasonable kind of gaps. So there's probably like a 0 about there, and 2 is reasonably there. Okay, and then you can count by 2s or whatever if you need to. I haven't really discussed how we'd like to see this, so I'm going to be lazy, and if we change it in class, then I apologize. But I want you to just get the idea. So remember, we're checking. Just like our other rules when we did graphing inequalities, for my x is greater than 2, this is an open point on 2, and it's everything to the right. For my x is less than -8, that's an open point on -8 and everything to the left. And so that's what would be shaded. If you notice, this was an OR problem, which means they're going to be pointing away from each other. Let's see it again here. I have -17 is somewhere down here on my number line, like 0's here on my number line, and 3's here on my number line. So we're going to check open or closed point. So for our first one, x is greater than or equal to 3. That's a closed point on 3, shading everything to the right. For my second point, closed point on -17, shading everything to the left. All right, this is an AND, so this is what an AND problem will look like. We have -8, we have 0, we have 5. We are going to have a closed point on 5, everything to the left, a closed point on -8, everything to the right. My arrows should be pointing to each other. That is what an AND problem looks like. It includes all the values in between. All right, and then finally an example here. When we're working with fractions, you may either want to convert these into a decimal or convert them into a mixed number so that you can tell where they should be graphed. That was awful. Okay, so if I'm going to convert this into a mixed number, I'm doing 3 goes into 20 without going over 6 times. That gets us to 18, and then 19, 20. That's 2 more left over. So that's really 6 2/3. So there's like a 6 here and a 7 here. And then if I'm converting this to a mixed number, 3 goes into 4 once with 1 left over. So here's 0, here's -1, here's -2. Okay, so with these, you are finding you're going a little bit past. So 6 2/3, we're putting an open point probably just before 7, and that's supposed to be shaded to the right. -1 1/3 is just past -1, open point, everything to the left. This was an OR problem. They're pointing away from each other. All right. I apologize if it feels like I'm speeding through this, but I don't want this video to be too long. So here's the steps. When we put it all together, we are isolating the absolute value. That means we're getting the absolute value by itself and moving anything on the outside of it. Once we've done that, or if there's nothing to move, we split into 2 equations. Okay, and at this point we can tell if it's and or that split point. Then we solve each equation and graph our answers. These notes will include some, I obviously don't have time to go through like every single scenario of each kind, but I gave a couple simple and one medium and one hard. So get my absolute value by itself. Done. There's nothing outside of this that needs to move. So my next step is to split it. X is less than 3. So it's my inside is the same, my inside is flipping negative. There's nothing to solve, x is already by itself, so now I can graph. We're doing an open point on 3 to the right, to the left. We're doing an open point on -3 to the right. This is less than, so it's an and problem. Okay, that's the most simple kind of version of this. All right, so I'm checking to see, first step, is there anything outside that I need to move? The answer is no. Second step, split this into 2. So I have the first one, 6n minus 1, is the same. And a second equation, 6n minus 1, is flipping negative. I'm going to solve each. First one by adding 1 to both sides to give me 36. Divide 6, and n is less than 6. My second one, I'm adding 1 to both sides. This is going to be -34. I'm dividing 6 to both sides, and n is greater than -34 over 6. It's not very friendly. If I were to convert that, that would be -5 and 4/6, which would also be 2/3. Okay, so we'll leave that there. So this is the same thing as this. So now when I go to graph them, open point on 6, everything to the left. Open point on -5 and 2/3, which is like right about here. Everything to the right. This is an and problem. Less than, and. And that's that. All right, example C. The first thing we need to do is isolate our absolute value. So we need to get this by itself by solving it. It's like inception. It's like a two-step equation inside of a two-step equation. So I'm going to subtract 6 to both sides. I'm going to bring that down here. So 31 minus 6 is going to leave me with 25 is less than 5 times the absolute value of 4 plus 9n. Now I'm dividing 5 to both sides. So the absolute value of 4 plus 9n is greater than 5. At this point, my absolute value is by itself, so I can split it. My first one is the same. My second one is flipping negative. And then I just solve each. So I'm going to solve this first one by subtracting 4 to both sides. So I get 9n is greater than 1. I'm then dividing 9 so that n is greater than 1 over 9. Okay, so I got a fraction for my first one. In my second one, I subtract 4 to both sides. I have 9n is less than -9. I divide 9 to both sides. And n is less than -1. At this point here, we are able to tell, so this says greater than, so this is going to be an or problem, great or, less than. So these should be pointing away from each other when I graph them. So let's see, n is greater than 1/9. So that's like an open point just past 0, somewhere there, and greater than. And then n is less than -1. I'm reading these from down here. So I find -1, and sure enough, that's less than, and it is or. They're pointing away from each other. There are a lot of pieces here. I Don't expect these to be done perfectly every time, but man, there's lots of room to make mistakes. There's lots of opportunities to make mistakes. So attending to precision and trying to be really careful about what we do is super important. Okay, I wanted to include a problem like this in the notes. If you see here we have 6 minus 5. Do not put these together to make 1. This 5 is attached over here trying to multiply. He wants nothing to do with this 6. He's got his own thing going on. He's trying to get into the party, and 6 is chilling out here. So we're actually going to get rid of the 6 first by subtracting it. All right, below now. That's going to give us negative 35, less than or equal to. I'm just kind of working backwards following this. Negative 5. Don't forget your sign. If that's a negative 5, it's still a negative 5. All right, now I have to divide that negative 5 to both sides to get my absolute value isolated, to get it by itself. If you notice, I divide by a negative on both sides, so my inequality has to flip. There are lots of little subtle rules. I wish we were in a classroom together to practice this. It would make it a little bit easier, but we're doing the best that we can. Okay, plus 2. So now, I wrote my line way too long here. Because now I need to split my absolute value into 2 equations. So my first one is the same, and my second one is flippin' negative. Oh, I got too excited to say flippin' negative. I wrote the wrong number. All right, I'm going to solve my first equation. Minus 2, minus 2. Sorry, I'll give you one of those. 5n is less than or equal to 5. Can divide this bad boy out. My 5s are awful sometimes. N is less than or equal to 1. I can look at this point here and tell less than, this is going to be an and. So I'm sending it. All right. Subtract 2. It's going to be negative 9. Dividing 5. Sorry, I'll color coordinate my steps here. And n is greater than or equal to negative 9 over 5, which would also be n is greater than or equal to negative 1 and 4/5. So now if I were to graph these, here are my 2 answers highlighted. This is an and problem, so they should be pointing toward each other. N is less than 1, or equal to, so it's a closed point on 1, shaded in. N is greater than or equal to negative 1 and 4/5. So negative 1 and 4/5 is almost a 2, and that's this way, and it was an and problem. They end up shading in toward each other. Okay, a lot going on, but you are capable of doing this. It's taking everything that we've learned about solving equations, solving inequalities, and solving absolute values, and we're compiling it all into one kind of like super equation or super inequality.